Welcome to The Explainer. Today, we're jumping right into something huge, the relationship between artificial intelligence and cybersecurity. It's complicated, and the stakes couldn't be higher. We're going to be walking through some really compelling ideas, all based on a presentation from the New York State Cybersecurity Conference.
All right, let's just start with this quote because, wow, it really sets the stage. Think about it for a second. Our national defense, our power grids, our finances, everything is digital. So the threat isn't some far-off what-if scenario anymore. It's here, it's now, and if we get this wrong, the consequences are, well, absolute.
So for a long time, the thinking has been pretty straightforward, right? AI is going to be our ultimate shield. It's this super smart, automated guard, standing watch, ready to fight off the nonstop wave of digital attacks.
And you can see this idea in action with something like Project Maven. Now, this was a huge deal. It wasn't just some lab experiment. This was the first time we saw deep learning AI get deployed on the actual front lines, sifting through hours and hours of drone footage. And the goal? It was massive. They wanted to kickstart a full-blown AI revolution across the entire Department of Defense. They were trying to prove, that this tech was finally ready for the big leagues.
Okay, so to really get what makes something like Project Maven tick, you got to understand how these different pieces of tech stack up. It's kind of like nesting dolls. You start with the big, broad idea of artificial intelligence, or AI. Then, inside that, you've got machine learning, which is all about systems learning from data instead of being programmed for every single task. And then, the deepest layer, the real engine behind Maven, is deep learning. That's where you get these super complex, multi-layered neural networks that can do some seriously sophisticated stuff.
But, and this is a really big but, here comes the twist. The exact same powerful technology we're using to build our best shields? Well, it turns out it's also perfect for forging the enemy's sharpest swords.
And this creates a whole new category of what the experts are calling invisible risks. And look, we're not just talking about your everyday computer viruses or those annoying phishing emails. No, this is a whole different level. We're talking about threats that are incredibly smart, incredibly deceptive, and way, way harder to spot. Why? Because they're built using the very same AI that's supposed to be protecting us.
So what does this new AI-powered attack toolkit actually look like? Well, for starters, you've got deepfakes, which can create super realistic fake video and audio to fool people and systems. Then there are these things called generative attacks. This is wild, where an AI makes tiny, almost invisible changes to an image to trick another AI into seeing something completely different. And maybe the scariest part? They can poison our own defenses by sneaking bad data into the datasets our AI models use to learn. It's like sabotaging the training academy.
So this brings up a huge question, right? If this technology is so powerful, so revolutionary, why does it keep failing? And not just failing a little bit, but failing in these really spectacular and sometimes dangerous ways. It's time we talked about AI's dark secret.
And I want to be clear, this isn't just some theory. This stuff happens in the real world. We've seen facial recognition systems, one of the most common uses of AI, go completely off the rails. There is a case where it misidentified members of Congress, matching their photos with a database of criminal mugshots. I mean, you can't make this stuff up. The results were just wildly inaccurate.
So where does it go wrong? A lot of the time, the problem starts with the data itself. See, most AI learns from our past. It looks at historical data and gets incredibly good at finding patterns and connections, what we call correlations. But here's the catch. It has absolutely no idea why those patterns exist. It doesn't understand causation. It's like a student who can memorize all the answers for a test but has no clue what any of it actually means.
And that points to a really fundamental flaw. For all its incredible speed and processing power, AI is missing some key human ingredients. It lacks intuition, it doesn't get context, it can't really grasp meaning, what we'd call common sense. It doesn't have that little voice in its head that says, hey, wait a minute, something about this just doesn't feel right.
This is what people are talking about when they mention the black box problem of AI. The system can spit out an answer, sometimes a brilliant one, but even the people who designed it can't always tell you exactly how or why it reached that specific conclusion. And if you don't know how it works, how can you possibly predict when it's going to fail? It makes preventing those failures almost impossible.
Okay, so all these failures, this whole black box thing, it really shows us that maybe trying to completely automate everything and take humans out of the loop, well, maybe that's a dead end. We need a major shift in how we approach AI altogether.
So check this out. We've got two different visions for AI. On one hand, you have AI automation, where the whole goal is just to replace human tasks. It's that mechanistic black box approach that we just saw can be super brittle and unpredictable. But on the other hand, you have AI augmentation. And here, the goal is totally different. It's not about replacing us, it's about enhancing what we can do. It's a human-centered approach that results in something way more robust and flexible.
This new way of thinking is called human-centered AI. And the goal here isn't to build some perfect, all-knowing machine that operates on its own. Not at all. The goal is to build a smarter tool. Think of it like a co-pilot for an expert. It's there to amplify that person's own intuition, their skills, their creativity, not to replace it.
And there's this one incredible, true story that shows exactly why this human-centered idea isn't just a nice theory, it's absolutely vital. Okay, I want you to picture this. The year is 1983. We are at the absolute peak of the Cold War. Deep inside a secret Soviet command center, alarms start blaring. An automated early warning system is flashing the most terrifying message imaginable. 5 U.S. nuclear missiles are incoming. Right now, heading straight for them.
Now, according to the machine, the logic was perfect, and according to military protocol, the rules were absolute. There was only one correct response: launch an immediate, massive retaliatory strike, an action that would have, without a doubt, started World War III and basically ended life as we know it.
But the final call wasn't up to the computer. It all came down to one man, the officer on duty that night, Lieutenant Colonel Stanislav Petrov. The entire fate of the planet was literally in his hands. So, what did he do?
He went against the machine. He completely broke protocol. He trusted his intuition, that deep-down human gut feeling that told him something just wasn't right. I mean, the data on his screen was telling him one thing, but the context was all wrong. A nuclear first strike with only 5 missiles? It just didn't add up. It didn't make any sense.
And his reasoning here is just so simple but so profound. And the craziest part? He was right. It was later confirmed that the whole thing was a false alarm. The super-advanced satellite system had mistaken the sun's reflection off some high-altitude clouds for missile launches. His decision, his human judgment, it saved millions, maybe billions of lives. I mean, Petrov's story is just the ultimate example of what we're talking about, isn't it? Full automation without a human in the loop carries an absolutely unimaginable risk. A computer can make a mistake in a fraction of a second, a mistake that could have consequences that we as humans could never, ever fix.
And that really leaves us with one last big question to think about. As we keep building these incredibly powerful AI tools, where should our real focus be? Is the challenge to build smarter and smarter machines, or is it to use these machines to become smarter humans?